Yes, welcome friends, welcome to the video of learning Python. Today we are going to start with what NumPy is and we are going to have some practical along with the theory. Right, so let's start. First is what is NumPy. So it is a fundamental package for the numerical computation with Python. Whenever we are using Python, we need this package for doing the calculation. So today we are exploring it. And what we can do, it helps us that using NumPy, we can manipulate data, we can create data, we can store data, and obviously it is a feature which is required to work on the databases. And this is also the foundation that Pandas is built on. In the coming lectures, we are going to learn, we are going to explore our knowledge regarding Pandas also. So we will do Python on Pandas platform. So what we are going to learn today, let's see. We will talk about creation of array, manipulating array, how to select elements from array, how to load dataset into array, and some other things related to all these which are common to the Python package program. So let's start. First thing is, whenever we are looking for start of a program, we need import numpy as np. Right, so we have to write down import numpy as np, and I need to import math because we are going to start some of the calculation. So let's start doing. Here is the screen where you can see we are working with. So the first thing I am going to write down is import numpy as np. This is the first thing, and the next thing is we are going to write down what the next we have is right. So we are going to write down import math and how to run. This is the platform, this is the Jupyter software that I am using to run all these for Python, and I am using NumPy. So I have written import numpy as np and import math, and obviously I am doing it in a fresh or an untitled file. Right, and how to run it, I need shift enter to make it execute. So you can see it is executed. Let's come back to PPT. What next we are going to do is, the next is how we can create a one-dimensional array. Right, so we must have to understand what an array is. Array is a collection of elements that are being combined together. Right, any collection of the similar elements that we are putting under the heading, we are calling it as array. And why it is required? It is required because whenever we are looking for some things to be done under the single heading, we need to create it as an array. Right, so here what we are doing is, we are saying a is equal to np.array. Here a is equal to np.array. So np.array is the syntax. A is the array that I want to create, and I am passing on to the list of arguments in square bracket as 1, 2, 3, and then we have a command print whenever I have something that I want to find out as an output what it contains. So we have a command of print. Right, along with that, whenever I am creating an array, I can check its dimension, and the syntax is, yes, you can note down, the syntax is ndim for dimension, ndim. And how to use it? I have used it as a.ndim. So let's start. Here what I am going to do is a is equal to np.array, now the normal bracket, and in this square bracket I am going to make out a list. So I have created a list 1, 2, 3, and if I will press shift enter, nothing happens. For in order to see what it contains, I need to print a. Right, so it shows me that it is having a list of 3 elements. Right, what next I have seen is, I have to print a.ndim. Ndim is for dimension. Right, so here I can see it is one dimension array, so the output is coming as 1. Now when I need to create a multi-dimensional array, what I can do? Obviously I need more than 2 rows and the number of columns. When we have talked about a single dimension array, means it is a list of elements being clubbed together, or I can say it's a single row with a number of columns. Right, rows we are calling as horizontally, and the vertical one are taken as for columns. So here we have another name b that I have used for this multi-dimensional array, and the first row is having element 1, 2, 3 that is being combined together, comma, again the second row having 3 elements 4, 5, 6, and then when we are talking about two-dimensional array, if I want to find out the length of rows and the columns, means how many rows and columns are there, I have a command shape, b dot shape. If b is an array, it is a multi-dimensional array. So I can find out the number of rows and columns by shape command. So let's start. Here and I am going to take b is equal to np dot array. Now what I have to do, I have a square bracket comma another square bracket. In the first square bracket, let me take any number 1 2 3, and in the second one let me write on 4 5 6. Shift enter, it's great. Again I want to print what my b matrix is. So here it is 1 2 3 in the first line, 4 5 6 in the second line. Now let's find out its, what we are saying, shape. We want to find out its shape. So it's saying me 2 comma 3, so 2 rows and 3 columns. Let's try to increase it, and obviously I have seen that the outside bracket is important. Let me put another array row and let me take 11 12 13 and press enter. Now again if I go for shift enter, it's showing me the updated one, and now I will go to the command and shift enter. It's now showing me 3 rows and 3 columns are there, right? So we have learned one-dimensional array, two-dimensional array, and how to see the dimension or shape. Shape means how many rows and columns are there. Now we are saying what are the type of items that are existing in the array. So whenever we are looking for the type, we have a command d type. Let us see the type of a. So I can say a dot d type, the data type of a. It's showing me int 32, means integer. And if I go for b, it's again the same. So let me manipulate. Let me just change the b matrix. Instead of all as integers, let me take some decimal value, and I am saying it's 1.1, right? Other as such, let me print or change. You can see the difference that I have given a decimal value only, and all others has automatically been given as dot behind. It means now it is considering being as the upper level of data type, integer and then float. So they are all being considered as dot. Shape is unchanged. So let me just check the data type. And now it's saying float 64. So this is the data type of B matrix now. So we have seen the data type. Now let's start taking some more initiative, and we are saying that in order to do some work, I need some initialization. Obviously yes. So here we have two commands that we are going to see, that if I need to create an empty array, so it can be created taking all zeros or all ones, and yes, the command is np.zeros. In between I can give the dimension, or np.ones, and will give the dimension. So it will create a matrix, an empty matrix with all zeros, or a matrix with all ones. Here we have, let us say here we have c is equal to np.zeros, and here we can put the dimension. Let us say I need 3 cross 3 is 3 rows and 3 columns, and let me see it. So let us say print c, and it's giving me 3 rows 3 columns. Let's create another one. Let me write down d as np dot. Now let us create of all ones. So for all ones, and let me change the dimension. Let us say 4 rows and 3 columns, right? And if I write d, you can print it or you can just showcase it. When I am just writing out the variable name, it's showing me an array as a whole, and otherwise it was showing me with the without name. No? So this is how we have arrays that are used for initialization. Next is that it is possible that we are looking to create an array with some random number. In some of the algorithms, it is possible that we are looking for generation of some random number. So here we have np.random.rent, and in the bracket I can provide the rows and columns. Means it will generate the random numbers in the range of 0 and 1. So let's verify. Here we have, let us say r is equal to np.random, and what is r? This is an array, 2 rows 3 columns, and by default it's giving me the the values from 0 to 1. Right? So this is how we can create a random array mentioning its dimension. Now we have the next thing is how to generate a sequence of number. Here we have a number of options that are available to do this thing. Here first one we are going to discuss is arrange. The syntax is arrange a comma b comma n, where a is the static bound, b is the ending bound, and n is the difference between consecutive numbers. It means if I will write down np.arrange 10 comma 50 comma 2, right? So 2 is the difference between the numbers. I will get the numbers starting with a gap of 2. So let's do np.arrange. So here I have written f is equal to np.arrange. Be sure that it is not the normal arrange, it is ARANGE, and here I am putting 10 comma 50 and comma 2 and shift enter, it's created. So if I run it, f is this. So it is inclusively 10, means it starts from 10 and 50 is the upper limit which will not be included. Right? So this is how we are using the arrange keyword to generate the sequence of number with a common difference. Now the another one is that if we want to generate a sequence of floats, for that we have another function linspace. Here we are saying n is not the difference, but it is the total number of values that I need to generate between two numbers taken from here, right? So let's start. N is equal to np dot linspace. From 0 to 2 I need to generate 50 numbers, so press shift enter and then I can say what is my n. Let me see, shift enter. So it's showing me that from 0 to 2 you can see the upper limit is here 2, the lower limit is 0 and the total is 15. Now we are going to start with that in Python the following mathematical operation can be easily done, such as addition, subtraction, squaring, exponent, as well as we can work with the Boolean arrays which are giving us the binary values, and we can even find out the matrix manipulation also. We can find out the product, make its transpose, find out their inverse, and a number of operations that you can explore. Here we have an example. Let us take A and B as two arrays. One is 10, 20, 30, 40, a list of 4 elements, and another is also I have taken of the same size because I can subtract the two arrays when they are of same size. Right? Here we have only a single row and 4 columns each. So what I can do, I can just write down C is equal to A minus B or D is equal to A into B, and I can print the result. So it is just a normal mathematics. So let's start. Here we have, so A is equal to np dot array. I need square bracket and let me take 10, 20, 30, 40 and I am creating B is equal to np dot array, and here it is 1, 2, 3, 4. I have created. Now what I am going to do is, let me say C is equal to A minus B, D is equal to A plus B, and let us say E is equal to A into B. And let me say I want to print C, I want to print D, sorry, and I want to print E. Right? So you can see first one is the difference of A and B, 10 minus 1, 12 minus 20 minus 2. The next one is sum of them, and the next one is product. Now here you can see I have taken two arrays, both are of size 1 cross 4, 1 rows 4 column, but they have been multiplied. It means it takes the element by element multiplication. So normal asterisk is helping us out doing the normal multiplication. Let's talk about the matrix manipulation, that if we have two matrix, here I have denoted as capital A and B, and I have defined 2 cross 2, 1, 1, 0, 1, 2, 0, 3, 4. So here we have that if we are using asterisk, then it will provide element wise product, just now that we have discussed. And if I want matrix products, have A is equal to np dot array, and let me take any random one. Here I need is 1 comma 2, let us say the first one. The second I am saying 2 comma 4, so I have taken 2 cross 2. Another I am taking capital B is equal to np dot array, and let us say here I need 2 comma 0 and another one 4 comma 1. So I have created two matrix. Let's see what they are. Let me print A, let me print B. So fine, A and B are there. Now what I want to do is I want to write down A plus B. Right, I'm getting the sum A minus B. Yes, it's fine. A into B. So you can see we are getting 2084. So what happened? We are getting 1 into 2. This is the first row elements, element wise. Then 2 into 0, 0. 2 into 4, 8, and 4 into 1, 4. But if I need the matrix multiplication, then I need to put at the rate B. Let's try. Yes, so this is the row into column. I think those who know mathematics, they can understand well that what is the difference between a normal element wise multiplication and the matrix multiplication. And I think we know how to find out the shapes, so already we did. Now we have to start with some inbuilt function. Now what the inbuilt functions are, that if I have defined some matrix, then I can find out the sum, the maximum, the minimum element, and the mean by writing out A dot sum, A dot max, A dot min, A dot mean. So these are the inbuilt functions that are helping us doing some mathematical calculations. So let's see. Let us see. This is my A. So if I will say I want to have A dot min. So the minimum element is 1. Let us say A dot max. It is 4, right? A dot mean. Mean means sum of all the elements divided by the number of elements. So here 1 plus 2, 3, 4, 5. 5 plus 4, 9. 9 divided by 4. It should be. Yes, it's 2.25. What else we have studied? I can find out the sum of elements also. I did it orally, but we can do it here. It's 9. Video we are going to talk about indexing, slicing, and iterating, because till now we have made our base of the arrays and vectors. Next time we are going to dive deep into it and we'll learn more things. Thank you so much. Have a good day.